The lie they taught you in school was simple. Energy flows through the wire. It doesn't. And if you still picture a copper wire as a little pipe with power rushing through it, then every time you flip a switch, you are misunderstanding what really happens. Ask yourself one honest question. When a light turns on almost instantly, which electron reached the bulb first? That question should bother you, because the electrons in an ordinary wire do not move quickly at all. Their average drift is astonishingly slow, often only millimeters per second. If electrical energy were being carried down the wire the way water moves through a hose, you would flip the switch and wait far too long for the lamp to respond. But you do not wait. The room lights up almost at once. So what moved fast enough to make that happen? Before we talk about circuits, I want you to feel the real actor in this story. Take a strip of plastic wrap. Rub it hard between your hands. Then bring it near the back of your hand without touching your skin. Your hairs rise. Your skin feels a pull, and nothing is making contact. No battery, no outlet, no power station, no wire. Just a force acting across space. People call this static electricity and then stop thinking. That is a mistake. What you just felt is the same interaction that binds electrons to atoms, makes chemistry possible, and allows ordinary matter to resist instead of collapsing through itself. That was not a trick. That was one of nature's fundamental interactions introducing itself. What changed when you rubbed the plastic? Charge shifted. A small excess of electrons built up on one surface. And here is the part human intuition is not built for. The electric force between two electrons is about 10 to the 42nd power times stronger than their gravitational attraction. A 1 followed by 42 zeros. So why does the world not fly apart? Because ordinary matter is almost perfectly neutral. Positive and negative charge are mixed together so closely that their enormous forces nearly cancel. Nearly. And nearly is enough. Disturb that balance by a minute amount and your skin notices. What feels like a tiny static effect is really a huge force that is usually hidden by balance. Now reconsider something even more basic. Touch. When you press your finger against a table, it feels as though two solid things have met. But at the microscopic level, what you experience is mostly electromagnetic structure resisting electromagnetic structure, together with quantum rules that prevent atoms from collapsing into the same states. That resistance is what you call solidity. The world feels mechanical. At its foundation, much of everyday contact is electrical. Now return to the switch. Electrons drift slowly. The effect appears quickly, so the wire cannot be a pipe carrying energy the way a hose carries water. Something else is doing the fast work. Here is what actually happens when you close a circuit. A metal wire already contains mobile electrons all along its length. Closing the switch does not launch a special packet of electrons from the wall toward the bulb. Instead, it changes the electromagnetic conditions of the entire circuit. An electric field is established along the conductors and in the space around them. That change propagates through the circuit at a speed comparable to light, shaped by the materials and by the geometry of the system. Then electrons all along the wire begin to drift in response. The drift is slow. The coordination is fast. That is why the lamp turns on so quickly. Now we reach the part most school diagrams quietly hide. In an ordinary circuit, the energy is carried primarily by the electromagnetic field around the conductors, not by little electrons hauling packets of power inside the copper. Charge moves in the wire. Energy is delivered by the field. That sounds abstract until you ask what voltage and current are actually doing. Voltage establishes an electric field. Current produces a magnetic field. Where those fields coexist, energy has a direction to flow. The wire matters enormously, but not because it is a pipe full of energy. The wire guides the field. It helps shape the path along which energy is transferred from the source to the device. You can see the result in something as simple as a filament. Charges drift through it. The material resists that drift. The charges scatter. The filament heats and begins to glow. But where did the heating energy come from? Not from electrons arriving like tiny delivery trucks with power stored inside them. It enters continuously from the electromagnetic field around the circuit. That is why the statement "energy isn't in wires" is not a slogan. It is the essential picture. And this clears up another confusion. Current is not power. Current is the rate of charge flow. Power depends on current and voltage together, on the full field configuration driving the charges. Notice what this means. The space around a wire is not passive emptiness. When a circuit is operating, that space contains electric and magnetic fields, and those fields store and transport energy. Change the voltage and the electric field changes. Change the current and the magnetic field changes. Change the geometry and you change how energy moves. Bring conductors closer together, separate them, twist them, add insulation, add shielding. You may not have changed the copper very much, but you have changed the field arrangement around it. That is why insulation is not just a wrapper around metal. It controls where the field can exist safely. If the field becomes intense enough, air itself can stop behaving as an insulator and become part of the path. That is a spark. The field found another route. So the wire is not the container of energy. The wire is the organizer. Now we can follow the energy back to its source. Somewhere far from your lamp, something is turning. A turbine spins, a rotor moves, coils of copper sweep through magnetic fields, and that should strike you as extraordinary. Why should mechanical motion in a distant building have anything to do with charges drifting in a wire in your house? Because electricity is not a substance. It is the controlled behavior of the electromagnetic field. When charges move, fields change. When fields change, charges move. That relationship is the engine inside every generator ever built. Here is the mechanism in its cleanest form. A changing magnetic field produces an electric field. Not current directly. An electric field, a push, distributed through space, telling charges which way to drift. In a generator, mechanical motion forces the magnetic environment of a coil to change. That changing field creates an electric field around the conductor. The charges respond. Current flows. That is the trick. No invisible fluid is injected into the wire. No energy substance is poured into the copper. A field is arranged. The field changes, charges respond. Now reverse the process. Drive current through a wire in a magnetic field, and those moving charges feel a force. The wire experiences a force. It moves. That is a motor. A generator and a motor are the same deep idea, run in opposite directions. Motion into electrical power, or electrical power into motion. And here is the deeper point. Electricity and magnetism are not two unrelated phenomena awkwardly tied together. They are two aspects of one electromagnetic field. Special relativity makes this unavoidable. What one observer describes mainly as an electric field, another observer moving differently can describe as a mixture of electric and magnetic fields. Magnetism is not electricity's separate cousin. It is part of the same reality seen from motion's point of view. The power grid uses this unity constantly. It reshapes the field again and again so energy can travel efficiently over long distances and then be transformed before it reaches your outlet. That is why alternating current matters. Drive alternating current through one coil and its magnetic field rises and falls. That changing field creates an electric field in a second nearby coil. Charges begin to move there too, even though the copper never touches. That device is a transformer. Now look once more at the apparently ordinary act of switching on a lamp. You press plastic. Two metal contacts meet. The electromagnetic environment of the circuit changes. An electric field is established along the conductors and around them. Charges begin to drift. A magnetic field builds with that current. Energy flows through the surrounding field, guided by the geometry of the circuit. At the lamp, charges drift through a thin, resistive filament. The material opposes that motion. Energy is transferred into the filament. Its temperature rises, hot enough, and it radiates electromagnetic waves. Some of those waves are visible light. They cross the room at the speed of light. They enter your eye. They push charges in your retina. Chemistry follows. Your nervous system turns that into brightness. So what is electricity? Not a thing, not a fluid, not a hidden substance moving through copper. Electricity is what we call it when charges and electromagnetic fields are arranged so that energy and information can be directed. And once you see that clearly, electricity stops looking ordinary. It becomes what it really is, a daily reminder that reality is not built from solid objects first. It is built from fields.